good old Newton returns, and we're looking at his understanding of what satellites are. When he was thinking about gravity, he noticed at the fall of the apple that something was causing it down. He came about with his universal law of gravitation. And he thought, now, since this gravity works with both earthbound objects and celestial objects, I wonder if that's what keeps the moon in orbit around Earth. And so he did a thought experiment. He said, okay, now if I have a planet here, planet Earth, and we could sit on top of a massive mountain, looks like a person with a party hat, but anyway, and we were to throw an object off that, it would be pulled down by gravity, projectile motion, and hit the ground. If we were to throw that horizontally with a greater velocity, initial velocity, it would travel further. And if I hit it out again, it'll travel further. But then he thought, I wonder if I could throw it with enough initial velocity that as it's being pulled back down, I might do this in a different color, as it's being pulled back down, the curvature of the Earth is falling away, and this object now returns to its original position, and it is in orbital motion. And he thought, okay, well, if that's possible, then the only thing acting on that body that's been thrown around that is now in orbital motion, because it's a projectile, is gravity, Fg. And so he said, okay, well, that is what we call a satellite. So Fg is controlling the orbit of objects around a central body. And he came up with that idea of satellites. And so therefore, the moon is in orbit, whoops, with a very wonky circle, right? That's a bit better, right? The moon is in orbit around the Earth, and its gravity, which also causes it to go around in a circular pathway as well. So that was Newton's thought experiment. So that brings us to the concept of satellites and describing satellite motion. So when it comes to satellites, there are two types of satellites: natural satellites and artificial. Now, natural satellites are things such as moons, right, if they're orbiting a planet, or planets if they're orbiting a star. So they're natural satellites. We could even say asteroids, right, the asteroids in our solar system orbiting around the sun. So there's some of the natural satellites. What about artificial satellites? Well, artificial satellites are those that we have placed up into orbit. And we can say that we have placed a lot of objects up into orbit, so much so that we have a lot of space junk around the Earth. And there are agencies that are monitoring the space junk and know where the space junk are, because if any fragments of those space junk hit satellites, they can do a lot of damage. In fact, here is a picture of a recent collision done to show you how much damage a very small object can do. This particular object was only a couple of millimeters in diameter, and look at the damage it can do. So you can imagine if you are in a spacecraft, the International Space Station, and you get some space junk hitting you, you'd be a little bit worried. So we've got to monitor all that space junk around there. But at the moment, there's around about 4,000 objects that are around there, that are things that are still in orbit. We have sent a lot more up there, but only about 4,000 are currently up there. But of those, I think it's about 1,200 or so are still in functional use. So from our artificial satellites, we can grade them or categorize them. So we can have low Earth orbit satellites, we can have medium, and we can have high. All right, so there's our three classifications. We're going to do this in a very large, I guess you could say, table, and compare the features of these in terms of their altitude, etc. And we might take one page each, and you can decide to build up, you can draw up a whole table if you will on your piece of paper, but we're going to look at each one in turn so that I can show you some pictures, etc. So let's start off with low Earth orbits. All right, let's start off with low Earth orbit satellites. And you can see here with this graphic here that low orbit satellites are fairly close to Earth. They only have an altitude of around about 150 to 2,000. Now the period of their orbit, right, so their orbital period is the time it takes to go once around the Earth, is 90 minutes. Right, and it can go up to nearly 4 to 5 hours. Now what are these used for? Well, these are used for research. So for example, research satellites for Hubble Space Telescope, for example. We can also use them for spying, right? So we know when you're doing your homework. Right now, spying in terms of like surveillance, military surveillance, satellites, etc. Now what are some of the advantages? Well, the advantage is that they're very close to the Earth's surface, so therefore they're very high definition in terms of surveillance cameras, right? The second thing is that they are low cost. You don't need a large cost to send them up to very, very high orbits like you would for the orbits of a lot of weather satellites, which can be up to 36,000 kilometers. What's another advantage of them? Well, it's very quick communication. Right? Because it's so close to Earth, the communication signals go backwards and forwards pretty fast. What are some of the disadvantages of having low Earth orbits? Well, the first one is that you have a greater chance of them interacting with the atmosphere, and so atmospheric drag, and therefore that can affect their orbital period, because as they hit the atmosphere they slow down, and that causes them to drift out of their orbit. You can also have heating effects from the atmosphere and the friction of the atmosphere, and that can cause damage as well. And they also need to be tracked, because there's so many of these low Earth orbits that they need to be tracked. Okay, what about the next class? Well, the next class, and depending upon where you read this, their class is Geosynchronous Satellites, and there's two different types of geosynchronous satellites. There's one which stay over the same position, which is called geostationary, and then the other class is also just called geosynchronous. So it's pretty confusing. But these satellites are a lot further out. So I'm going to write it over here, and we can show any pictures over there. All right, so geostationary and geosynchronous. As the name implies, geo is Earth, is land. They somehow synchronize them, and chronos is time. So with geostationary satellites, they stay over the same position. As you can see here in this little graphic, they stay over the same position in the sky. So if you're looking up, it will look to you that satellite is stationary. It's not going anywhere. It's straight over you 24/7, right? So in terms of altitude, it's greater than 2,000 to 36,000 kilometers. Okay, the period, because it's geosynchronous, it has to have a period that equals a day length of the Earth, and so you're looking here at 23 hours, 56 minutes, and 4 seconds. Right, so that's the period of rotation for a geostationary satellite. Well, what do we use them for? We use them for communication. So, that's a great advantage. If they're not moving throughout the sky, you know exactly where to point your satellite dish and where to get a signal. A disadvantage is that they're costly. So geostationary, same position, same location. So the advantage is that you don't have to track them. You know exactly where they are. Well, what about geosynchronous? Well, actually, before I get onto geosynchronous, we should say about geostationary, they have to have an equatorial orbit, right? They're around the equator. So you can see that in this graphic here, they have to be equatorial. What about geosynchronous? Well, geosynchronous is very similar to geostationary. It's a similar distance. They've also got to have a period, that is the day length. But their orbit can be different. It doesn't have to be equatorial. It can be polar, going up and down the North Pole, just like you can see here. And the good thing about that, the advantage about that, it can sweep across the whole surface of the Earth, from North Pole to South Pole. So as the Earth is spinning on its axis, this satellite will be going up and around, and it can survey the whole surface of the Earth, geosynchronous. It can be on a slight angle as well, so you know, it doesn't have to be limited to the equatorial orbits. Now, what's another disadvantage of both of these is that you have to have stronger signals to get up to this orbital distance, and also you have to go through the ionosphere, and so therefore you're getting you can get some communication blackout sometimes as well, right? So stronger signals. So that's a quick comparison of those three different types of satellites and their advantages and disadvantages. Hopefully that makes sense to you. But these are important to understand, because these artificial satellites, we can maneuver them by changing a variety of their features. So we can change their orbital period, we can change their orbital velocity, and by doing that we can affect their altitude and a lot of other features as well. And we're going to get into this in the next series of videos, where we start exploring these terms and Kepler's laws in the next couple of videos after that as well. Hopefully that makes a bit more sense to you about the different types of satellites, natural versus artificial, and the three different classes of artificial satellites, their types of orbits and their uses and their advantages and disadvantages. Okay, see you in the next video.